Hi all, here we are going to discuss about another graph traversal method known as depth first search. You may be knowing about this, you have already learned in data structures as breadth first search. The method followed by depth first search is, as its name implies, to search deeper in the graph whenever possible. Depth first search explores edges out of the most recently discovered vertex V that still has unexplored edges leaving it. Once all of the V's edges have been explored, the search backtracks to the explored edges, leaving the vertex from which V was discovered. This process continues until we have discovered all the vertices that are reachable from the original source vertex. If any undiscovered vertices remain, then depth first search selects one of them as a new source and it repeats the search from that source. The algorithm repeats this entire process until it has discovered every vertex. Coming to how we are going to explain this depth first search, we use the same coloring method as we used in breadth first search. It is initially, it has vertices can have three colors: white, gray, and black. It is vertices which are go in the initial stage. Gray is when they are discovered, and black when they're finished. Now, just remember the term which has been given below: depth first search forest. It is a predecessor subgraph containing multiple depth first trees. There are many cases when from a particular node it has to backtrack in order to find out another way, or in order to find out the other adjacent edges. So each and every path which goes from node which can be traversed, that is considered to be another depth first tree. Multiple depth first trees form a depth first search forest. Just remember this word. We will come to it later on when we go through the examples. Coming to the code of depth first search, there is an initialization part, then it goes on finding out the traversal. DFS is depth first search, and the input for that particular code is a graph. Initially, it initializes all the vertices to color white. There is a globally used time variable which is initialized to 0. It is with this time that it considers whether it has been traversed or whether it has been explored or it has been finished exploring. So time is one global variable which is initialized to 0. Next is for each vertex u belonging to g dot v. G is the graph, V is the set of vertices. So one by one, each and every vertex is taken. It is checked for the color. If it is white, that means it has to be explored, it has to be traversed. And a DFS underscore visit recursive code is run for each and every vertex. Now that recursive code is written on the right hand side of the page. In that, whenever a white node is encountered, it is made gray, the time is incremented, and another time is assigned. Basically, while the traversal is going on, there are two different types of time. One is the discovering time and one is the finish time. The discovering time, which is represented as u dot d, and the finishing time at the end of the code, it is written as u dot f. The time when you arrive at a particular node for exploration, that means the gray leveled code node, it is that u dot d. When it has finished its exploration, that means no more nodes to be considered from that particular node. That means you are going to color it black, then that is the finish time. The explanation has been over. So the code is very simple. When you get into a code, when you get into a white colored node, it is made gray, the time is incremented, and the arriving time is put as u dot d. Then You go for all the adjacent nodes from that particular node one by one. The whole traversal is done depthwise. It is either it takes the left path or the right path. It goes deeper, 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 unless no more deeper you can go, and then it backtracks. That is done in the second for loop. Then later on, once the whole path has been traversed, that means no more paths to be gone through, it is made black, time is incremented, and a finish time is assigned. So let us try to understand this with an example. This is a example where you have nodes from S to Z. S is unless and until shown. Here S is taken as a source vertex, or either it has to be shown, or either if it is not shown, S is taken. Anyone you can randomly take it as a source vertex. You have to show which is the source vertex. So S, T, U, V, W, X, Y, Z. S has an outgoing edge to T as well as to V. T has an outgoing edge to U and V. U has an outgoing edge only to S. V has an outgoing edge to U only. W has an outgoing edge to V and X. X has an outgoing edge to V. Y has three outgoing edges to W, X, and Z. Z has an outgoing edge to V. So when you write an adjacency list for this, S will be having an adjacency list with two nodes, that is T and V. T will be having again two nodes U and V. U will be having only one, that is to S. V will be having only one, that is to U. You know how to make an adjacency list. So this goes on. It is with the help of this adjacency list that these traversals take place. Along with the information about the node, as I said, there are two different times that has to be allotted. This one is the arrival time, one is the finish time. Now let us start the traversal. Initially, the source vertex, that is the S, it has two different times, that is D and F. It has started its traversal. Just to make this slide much more colorful, the gray, I have just replaced the gray colored with a purple. So don't mistake, it is the code is with gray only. Only thing, it is for representation that I've put that purple there. So wherever you see the purple color, just try to take it as gray. So starting from the source vertex, the arrival time, that is the D time, is 1. As we have already said that it has to move to T and V, either T or V. So usually the practice is that we cover the left side first and then we go to the right side. So from the adjacency list, you can get the information about the T node and it goes to the T node. So that particular T is made, the arriving time at T is 2. Again, there are two different outgoing from 2. One to U and another one to V. So it goes there. Again, the arriving time there is 3. From 3, it has outgoing to the source vertex, but the source vertex is already under consideration, so you needn't go again to there and again pass the same thing. So what you have to do is that U vertex is stopped there, made black, and the finishing time is recorded. Now it has to backtrack to T. It is where the 2 has been written. So from that T vertex, it has to then go to V, because it had 2. One has been explored, the other one you have to do. So a path from T to U is one depth first search tree, another one T to V is another depth first tree. This becomes a forest. This multiple paths become a forest. That is what we discussed earlier. Now coming to the V vertex, V has an outgoing to U. It's already done, so you have to go back to 2 first, so making it black, and recording the finish time, it has to go to black, sorry, go to T. There again there is no outgoing edges more to be considered, so the T vertex is made black, finishing time is 7, it goes to the source node again. Now from the source node there is a outgoing to W. Now that W has an outgoing to X, and from that X there is no outgoing, so it is, there is an outgoing but it's already done, so it has to be made black, and then it goes back to again W. This goes on. Hope this can be, it's very self-explanatory. This goes on. Now it comes to, next it comes to the source vertex. Now this is over. This one complete search, it has come back to the source vertex. Now this particular forest has been over, but the graph traversal is not over yet. There are 2 more nodes to be traversed again. Now you start with the 2 more nodes to start, as well as 2 that you can put it in another way, it is unexplored. So you will start, because it's those are white ones, you can start the DFS search again from there. It's the 13th time, it's a continuation, it's the 13th time towards 8 and towards 9 it has been already done, so no need about that. Then you just have to go to Z 14, all the rest has been already done, finish it, go back to Y, and that's already done. So from this final one, all the vertices has been made black. You have all the arriving times 1 2 3. Again after that the node was 5 8 9 13 14. Now each and every node after exploring, when was it finished or when was it over, when was it made black, that is also recorded. So it's easy for a traversing method to find out when was it arrived, or you can find out the path easily. Here the paths have been colored red, all the other one which has not been gone through but it is available there, not gone through or not used, those are black as it is. So this is how depth first search works. So hope you understand this. Any doubts you can clarify in my mail or through phone. Next, one more topic which has to be attached to this portion is DFS kinds of edges. There are 4 different kinds of edges, what we have already discussed, but giving a name. Tree edge, encounter a new white vertex. Back edge, from the descendant to the ancestor. Forward edge, from the ancestor to the descendant. Cross edge, between a tree or subtrees, that is from a gray node to a black node. You can understand it with this example. Tree node are the white nodes or edges that connect the white nodes. Back edges, it's from the predecessor, sorry, from the descendant to the ancestor. Forward is from the ancestor to the descendant. And cross edges are between the trees and subtrees. So this is how it goes. The red marked arrows are tree edges. The brown ones are, that is from 3 to 1, that is a back edge from the descendant to the ancestor, from the lower level to the higher level. Forward edges from the higher to the lower, 1 to 5, no issues. And the cross edges are the edges which connect the tree or the subtrees. So just remember these names which can be used. Any doubts in this portion, you can just give me a mail. Thank you.